Hello, my name is Andrei. Welcome back. In this video, I'll talk about Sparrow Parse. This is the Sparrow library that I'm implementing, and the main idea is to help LLM process invoice, receipt, or any other unstructured data in a better way. And it works only not in a way that it helps LLM to process data by pre-processing the data, but there's another component of Sparrow Parse that directly extracts data from HTML table structure. And we're using combination of LLM and also classical NLP ML models to get to convert the table structure into HTML to detect columns, and then reading the column data directly by the column name if the column name is matching the request from basically the field from the query request. And the code for the Sparrow Parse is not yet on the GitHub because this is work in progress. I'm testing it, and I'm testing it how it works in a case if there are multiple tables inside the document, for example, and with some other complexities. And I'm testing not on a simple documents, but on actual documents from our customer, on real life complex documents. Yeah, so this is the Sparrow Parse, and actually initial version of Sparrow Parse is already on the GitHub, but the code that I'm showing here is not yet on the GitHub. The idea is just to explain you what is coming in the next version of Sparrow. So this extractor component, which contains three scripts for the moment, Markdown processor and Unstructured processor, and Unstructured processor relies on Unstructured library, and we're feeding file, either PDF or image, and we're getting back elements. And then using those elements, we're loading text. And there is other option when we load full text as is from the document, or if we specify option that we want to process tables in an HTML format, then we are loading two types of information. First one is let's say content of the document. It can be either entire content or just form content without the tables, and then LLM will be used inside main Sparrow application to process this form data. And the second part is table, because with Unstructured we can detect one or more tables located in the document, and then this table format we get from Unstructured is HTML, so we can access headers and values directly through HTML structure, and we return that. And we are not, at the moment, we are not using LLM to process table, because I noticed that at least for the local open source LLMs and for ChatGPT, even if table structure is more complex, it may struggle with the table processing, and there are high chance of data hallucination and high chance of the option that that incorrect data will be received. So what I'm doing is I'm returning back to Sparrow HTML table produced by Unstructured, and I'm using LLM to detect table column names, headers only, and then I'm matching those headers with fields from the request, and then I'm sending request will be sent to Sparrow Parse to directly extract the column values based on the matched column name. Yeah, so this is how it works, and then the table processing speed will be much faster, because we'll just access table directly without going through LLM in this case. So that's for the Unstructured, and in Sparrow Parse we don't want to rely on a single library like Unstructured. This another dependency, completely separate implementation, where we rely on PyMU PDF for LLM, and this library converts PDF file to the Markdown format, and then for example, for some of the documents, Unstructured is not able to process well the document, but to Markdown conversion it works quite well. And for other kind of documents, it can be other way around. So basically, based on your specific use case, there'll be option to test with parameter either use one approach or another. And maybe we'll add third option as well with some ML library which auto-detects tables, for example. So there'll be one more approach which converts tables to HTML, and there'll be possible to switch between those approaches when you're using Sparrow Parse. So in this case, we also extract non-table data, extract table data, and then when we extract table data, we convert it using pandas data frame, we convert to HTML. And it works. This approach works quite well as well, I would say, because for the complex tables, sometimes it works even better than unstructured library. And as I said, that for some other type of documents, unstructured works better, for example. So it depends. So we return to the Sparrow, in this case, raw HTML data. Then the task of Sparrow is to detect column headers. And then in a second step, Sparrow invokes HTML extractor from the Sparrow Parse. And it's passing the original table that was extracted in the step before, and it's passing the list of columns that we're interested in, and from those columns, the values will be extracted directly using HTML extractor. So HTML extractor works with the HTML table directly, and it looks for the columns that we're interested in. In this case, we're using sentence transformer model, all MP-net base v2, and with the help of this model, we identify similar columns that match with query fields that we are looking for to extract. And then, based on those column names, we are extracting the data, just reading the data directly, extracting columns from the table, and returning back JSON. Yeah, so this is the idea. To summarize, there'll be option in Sparrow to rely on LLM for the form data processing, but whenever table will be located, then we'll provide additional functionality where we will extract data from the table content directly by relying on the column names without relying on LLM, to reduce number of hallucinations and to reduce situations when data is lost by LLM processing. So thanks for watching, and see you next time. Bye.